controllers and what is hindering us.
Yeah.
Well, this is an interesting point. It's something that we do not understand completely well so far. Maybe we start understanding it now. I myself was mistaken at the beginning, I believe. In some of our early work, we tried to, we understood that robots should have compliance, so we built compliant robots. But then we started controlling them, trying to make them follow pre-specified trajectories as accurately as possible, according to control paradigms that are sort of traditional. So these paradigms typically try to alter the dynamics of the system by imposing some other model. So a typical example is a method that is known in nonlinear control as feedback linearization, whereby you fundamentally cancel the nonlinearities by control, by using the model, and then you add a different structure that is more suitable for what you desire to have done as a task. But if you do this, then basically you are destroying the dynamics that you have built in the system, and then you are imposing some other model by the controller, and which really defeats the purpose of building soft robots. So we realized that, and the same effect of destroying the natural dynamics of soft robots is obtained if you use high gain, even simple controllers like high gain PID. So these controllers do not exploit the dynamic structure of the system of soft robots, do not exploit, for instance, the elasticity, not exploit the resonance, and those characteristics that make compliant bodies, in some senses, better or more suited for the task. So then we've started in recent years started looking at how a controller should rather approach the problem so that you can get the task done, but without altering the natural dynamics in the system. And this means that in some sense you have to rely much less on the feedback, on the high gain feedback, and have a relatively low gain feedback instead. And to compensate for the error, you have to use feed forward. Feed forward means that you have learned somehow how the body will move under some circumstances, and this will, if you learn this model, then you will learn how to control the robot while keeping soft. And this is some work that we have been doing in recent years. It's very interesting because it's also parallels what it seems humans are doing in their learning phases when they're very, very young. Kids start exercising and try to understand how they control their limbs that are soft, elastic, in a way that respects the dynamics and simply sends the right command at the right time to the system. So I think this is very inspirational and something that we want to continue working on. Now there's a large number of people that are interested in using more of this approach that is mixing feed forward and feedback in the right way.